What if a multi-billion-dollar oil refinery could be taken down by drone?
At 1:47 a.m., long before dawn touched the edges of Europe, the darkness above northern Ukraine vibrated with a different kind of tension. Deep inside a concealed launch site hidden beneath an abandoned orchard, Ukrainian operators prepared a mission that would echo more than 1,020 kilometers into Russian territory. Their ultimate objective, the Kirishi refinery, processed over 6.2% of Russia's national fuel output. If their calculations held, that percentage would drop to zero before the sun climbed over the Baltic. But tonight, Ukraine needed more than precision. They needed an opening blow, something sharp enough to punch a hole through Russia's early warning net before the main swarm even took off. At 1:52 a.m., the first wave launched 14 UJ-22 drones, each weighing little more than a motorcycle, but carrying the power to blind a regional command sector. Their target wasn't high-value infrastructure. It was the Neville Early Warning Radar Site, sitting roughly 50 kilometers from the Belarusian border. A small, outdated node Moscow assumed no one would bother striking. The UJ-22s skimmed treetops at 80 meters, slipping through gaps in the radar horizon. By the time Russian operators noticed unidentified low-altitude anomalies, the drones had already breached the perimeter. 3 slammed into the generator hut, erupting into a fireball that severed half the antenna grid. It wasn't a massive explosion, but it was decisive. The radar feed flickered, then died. An S-300 crew nearby fired 2 9LM-82M missiles, each costing nearly $3 million, just to destroy the few stragglers spiraling overhead. Millions spent to counter drones cheaper than a family sedan. The imbalance was only beginning. By 2 a.m., the night sky over Ukraine had begun to shift. The small UJ-22 strike on Neville had done exactly what planners hoped. Russian early warning radars were momentarily blind, recalibrating, second-guessing themselves. And in that narrow window, the main operation unfolded. The first FP-1 accelerated off its rail, climbing to 85 kilometers per hour before its wings stiffened and carried it northeast. 15 seconds later, another followed, then another. Within 4 minutes, over 30 FP-1s were airborne from just this single orchard launch site. Across central Ukraine, similar scenes played out. Barns, highway rest stops, factory rooftops, even a disused grain silo, converted into a midnight control hub. By 2:18 a.m., the total airborne count had risen to nearly 350 drones. Yet what looked chaotic was actually a synchronized machine. Ukraine's backward planning model assigned each strike group different cruising speeds. FP-1s at 210 kilometers per hour, secondary UJ-22 groups at 155 kilometers per hour, decoy Mugen 5S at 135 kilometers per hour, all so they would converge on their respective targets inside a 20-minute attack window. One swarm, many directions, but a single moment of impact. Russia finally detected something unusual around 2:23 a.m. A radar post near Bryansk reported multiple low-signature tracks climbing steadily. At first, operators dismissed them as atmospheric clutter, but when the count reached 41 separate returns, panic followed protocol. MiG-31 interceptors scrambled from Baranovichi, slicing through the night with Zaslon M radars sweeping at full power. They immediately locked onto the higher Mugen 5 decoys, exactly what Ukraine intended. Every kilometer the fighters climbed was a kilometer they weren't looking for FP-1s hiding just 50 meters above the ground. At 4 a.m., the Kirishi strike package, once nearly 30 drones, had been whittled down to 26 as it approached the Belarus-Russia frontier. The air grew heavier, the ground flatter, and the defenses thicker. This was the moment Ukraine had spent months preparing for: the penetration of Russia's most fortified air defense belt. The formation shifted with mechanical precision. Mugen 5 decoys climbed past 3,200 meters, radiating spoofed telemetry and carrying oversized radar reflectors. UJ-22 intercept absorbers leveled at 1,600 meters, their fuselages reinforced to survive near-miss shockwaves. Then Russia's cheese grater radar, the 9S-19M2, part of an S-300 battalion near Tiktan, caught a flicker. The system frequency hopped over 110 times per second, designed to be immune to jamming. But Ukraine had learned its flaw months earlier. Every 10 seconds, the radar paused for 0.5 seconds to recalibrate. Half a second of blindness, enough if you knew when to move. A single Mugen 5 sacrificed itself to expose the timing. It climbed to 5,100 meters, broadcast its signal, and triggered the S-300's 3.1 million 9 M82M missile. In the 2 seconds before impact, its transmitter captured the radar's reset rhythm and passed it to the swarm. 25 drones dove simultaneously. For half a second, the radar saw nothing. When its beam returned, the sky was empty. The drones had slipped beneath the horizon, hidden by the curvature of the Earth itself. At 6:19 a.m., the strikers broke through the final defensive layer. Kirishi's vast industrial glow rose over the tree line, fuel tanks, cracking towers, and pressure lines stretching for kilometers. The swarm had reached its objective. The explosion to come would reshape the entire night. At 6:20 a.m., the first detonation at Kirishi ruptured far more than steel and concrete. It shattered the delicate balance of a refinery built across 5 decades of Soviet and post-Soviet expansion. The blast from the initial FP1 strike tore through the CDU, 100 primary distillation unit, generating an overpressure near 95 psi. Enough to shear corroded support frames that had not been fully replaced since 1987. Superheated crude, nearly 375 degrees Celsius and pressurized at 29 atmospheres, erupted from the severed lines. The moment it met the air, it flashed into vapor, creating a rolling fire front that raced down the pipeway corridors at nearly 900 meters per second. Operators had no time to activate bypass valves. Within seconds, flames engulfed multiple wings of the distillation complex. Then the second FP1 impact struck Tank 47, a floating roof tank holding more than 82,000 barrels. The weakened seal ignited instantly, turning the vapor layer beneath the roof into an expanding gas bubble. The 47-ton steel lid launched over 180 meters, arcing across the yard before crashing through the roof of an administration hall. The shockwaves destabilized the fractionator column, already starved of feedstock and suffering rapid internal pressure swings. With internal temperatures still above 380 degrees Celsius, the sudden drop triggered a boiling liquid expanding vapor explosion, a BLEVE, that split the 40-meter column along 3 separate weld seams. The upper section blasted nearly 850 meters away, leaving a crater of twisted pipes and burning insulation. Automatic sprinkler systems attempted to activate but failed almost instantly. The first explosion had severed the main water trunk. Emergency pumps lost pressure, and with valves jammed by heat, the refinery effectively lost all ability to contain the catastrophe. By 7 a.m., Kirishi was no longer a refinery. It was an interconnected chain of detonations, systems collapsing in sequence one after another like dominoes engineered to fall. By 7 a.m., the Kirishi refinery, once a sprawling complex processing nearly 360,000 barrels per day, had entered a state no emergency protocol had ever been designed to handle. With the main water trunk severed and auxiliary pumps burnt out, the fire suppression grid collapsed in under 2 minutes. What remained was a refinery forced to fight a multi-tier industrial disaster with no functioning systems. Flames had grown into vertical towers, some reaching 140 meters, hot enough to deform structural steel in less than 5 minutes. The blast that launched Tank 47's roof now ignited 6 neighboring storage tanks as radiant heat climbed past 1,150 degrees Celsius. Each tank held between 50,000 and 90,000 barrels, and their sequential ignition transformed the western section of Kirishi into a storm of fuel-air detonations. The catalytic cracking unit, the heart of the refinery, lasted only a moment longer. Shockwaves from the bleave had ruptured its primary riser, causing catalyst slurry at 520 degrees Celsius to spill across the concrete aprons. When it met leaking hydrocarbons, an expanding pressure front swept outward at nearly 2,000 meters per second, punching holes through heat exchangers and severing pipe racks that carried diesel, naphtha, and vacuum gas oil across the facility. Inside the control tower, systems went dark one by one. Distributed control nodes melted, power relays failed, thermal sensors reported impossible numbers, 1,300 degrees Celsius, then 1,420 degrees Celsius, then nothing at all. Operators abandoned the structure as the glass windows began to soften. Satellite imagery captured the scale of collapse in brutal clarity. A plume stretching over 7 kilometers drifted toward the Gulf of Finland. Russian authorities attempted to isolate the eastern compartments, but without functional valves or pressurized water, containment was mathematically impossible. Kirishi's network of pipes, over 47 kilometers of interlinked conduits, conducted heat like arteries feeding the fire itself. By 7:30 a.m., the refinery that supplied over 6% of Russia's refined fuel capacity was no longer functioning in any coherent sense. What remained was a burning, self-destructing labyrinth, one whose damage would take months to understand and far longer to repair. By the time the sun lifted over the Leningrad region, the Kirishi refinery was no longer an industrial asset. It was a scar, a sprawling, burning wound carved into Russia's fuel infrastructure, visible from space-based sensors that tracked the plume stretching nearly 30 kilometers across the Baltic winds. What had begun at 1:47 a.m. with a handful of low-cost drones had cascaded into the largest refinery disruption Russia had faced in over 3 decades. Emergency teams struggled to approach the site. Temperatures across key sectors fluctuated between 900 degrees Celsius and 1,200 degrees Celsius, hot enough to liquefy aluminum fixtures and buckle steel beams rated for extreme industrial stress. The collapsed fractionator column left a crater 20 meters wide, glowing beneath layers of molten insulation and fractured concrete. Surveillance drones detected more than 240 individual fire pockets, each fed by different broken pipelines still venting hydrocarbons. Inside Moscow, the shock was immediate. Kirishi's loss removed 6.2% of national refining capacity in a single morning. But the real impact ran deeper. Over 1.8 million barrels of semi-processed product stored across connected tank farms were now inaccessible. Regional pipelines feeding St. Petersburg refueling hubs reported sudden pressure collapses, forcing emergency rerouting procedures that had not been used since the early 1990s. Economic analysts quietly projected that even an accelerated recovery plan would require 5 to 7 months just to revive partial operations. Full restoration, especially of the catalytic cracker and vacuum distillation train, might take a year, assuming replacement components could be sourced and delivered under sanctions. More troubling for Russian planners was the doctrinal failure exposed by the attack. The integrated air defense network, built at enormous cost to counter strategic bombers and hypersonic threats, had been outmaneuvered by drones built from hobby engines, commercial GPS boards, and plywood. For years, Russian doctrine assumed that layered defenses, expensive interceptors, and long-range radars could deter any aerial threat. But Kirishi proved a different truth. A refinery worth billions can be undone by weapons costing less than a single minute of fighter jet flight time. And as smoke drifted over the Baltic, one fact became unavoidable. This was not simply an explosion. It was the arrival of a new era, where industrial warfare could be rewritten by machines small enough to fit in a garage, but powerful enough to reshape a nation's energy map. By the time the last flames at Kirishi dimmed into smoldering orange lines, one truth had become impossible to ignore. The battlefield had changed forever, not because of the size of the explosion, not because of the distance the drones traveled, but because of what the attack revealed. An asymmetry so severe that it rewrote the rules of industrial warfare in a single night. A refinery worth billions, protected by layered radars, interceptors, autocannons, and one of the most expensive integrated air defense networks on Earth. was undone by aircraft no heavier than a suitcase and built from components anyone could order online. Russia's most fortified sectors, calibrated for bombers and cruise missiles, suddenly found themselves vulnerable to engines that cost less than a household appliance. And the fallout stretched far beyond the fire itself. Kirishi supplied over 6% of Russia's refined fuel, fed regional aviation hubs, and supported critical logistics across the Northwest. Losing it in a matter of hours wasn't just a tactical setback, it was a strategic fracture. One that rippled into energy markets, supply chains, and military planning rooms from St. Petersburg to Moscow. But perhaps the most important question isn't what was destroyed, it's what comes next. Because if drones this small can tear open the armor of a multi-billion-dollar refinery, what does that mean for every other critical facility drawn inside the range of modern UAVs? What does it mean for future conflicts, for national infrastructure, for the balance between cost and firepower? And more importantly, if you were the commander responsible for defending a site like Kirishi, what would you change after tonight?